If we have an inductor in the system and the current that is passing through this inductor is periodic, 1, no power is consumed or absorbed by this inductor. 2, the average value of the voltage drop across that inductor is 0. Okay. Now, we can make the same argument for capacitors, all right? But just they are kind of dual of each other. So instead of talking about voltage, we have to replace voltages with currents and currents with voltages. So before we were talking about an inductor with a periodic current. Now we are talking about a capacitor with a periodic voltage. All right. So obviously you know that this is the symbol that we use to show a capacitor, and I've used a passive sign convention, positive here, negative here, and the current is flowing from positive to negative. V sub C, C stands for cap, so that means I'm highlighting the voltage of my cap, and I sub C, that's the current of my cap. And we already know that there is this relationship between the current and the voltage of the cap. Current of a cap is the value of the cap times the derivative of its voltage. All right. So now, similar to the previous fashion, but I didn't really write the equations over here, you can also argue that if the voltage that appears across this capacitor is periodic, there won't be any power consumed by this capacitor. Also, if the voltage that appears across this inductor is periodic, the average value of its current is 0. That means on average the capacitor is neither getting charged nor discharged. Okay. Any questions? Okay. So these are two simple principle kind of rules or conclusions, and I want you guys to remember it. Just make sure for inductors we care about currents to be periodic. For capacitors we care about voltages to be periodic. Okay? All right. Now, another definition that we use often, because after all this is a power class, and in order to calculate the power you definitely need the RMS value of a signal. So we are going to talk about root mean square or RMS value of a signal. Okay? So first of all, please remember, most of the times your signal has to be